Every time you send a text on WhatsApp or pay for an overpriced latte via your banking app, you're using a digital lock so strong that all the world's supercomputers working together for 10,000 years couldn't crack it. Except, in a few years, a new kind of machine could pick that lock in about 3 minutes. And here's the kicker: intelligence agencies and hackers are already stealing your data today. They can't read it yet, but they're hoarding it in digital warehouses, just waiting for the day the magic math eraser arrives. Welcome to the countdown to Q-Day, the day current encryption dies. We used to think we had 50 years, but thanks to a massive breakthrough in March 2026, that timeline just went through a paper shredder. To understand how we break the internet, we have to understand how we locked it. Most of your digital life is protected by RSA encryption. It's based on one simple, annoying fact. Math is easy to do, but hard to undo. Multiplying two prime numbers is a breeze. 13 times 17 equals 221. Easy, but if I give you a number with 617 digits and tell you to find the two prime numbers that made it, even Google's best supercomputers would be chugging away for millennia. This one-way street of math is the ground truth of our security. In the world of classical computing, we deal in bits, ones and zeros. They are like light switches. They are either on or off. To find the key to a lock, a classical computer has to try every single combination, one by one. It's a slow, grueling lecture that never ends. Quantum computers don't use bits, they use qubits. Thanks to a property called superposition, a qubit can be a 1, a 0, and every shade in between, all at the same time. This isn't just faster computing, it's exponentially faster. Think of a maze. A classical computer tries one path, hits a wall, backtracks, tries another, one at a time. A quantum computer, it fills every single path of the maze simultaneously and finds the exit instantly. In 1994, a mathematician named Peter Shor realized that if you had enough of these qubits, you could run Shor's algorithm, which finds those impossible prime factors in minutes. For 30 years, cryptographers were like, "Cool story, Peter." But a quantum computer that big would need millions of qubits. We're safe for decades. Then came March 2026. Google's quantum AI team and a startup called Oratomic dropped a bombshell. Before this, we thought we needed 20 million physical qubits to break the encryption used by Bitcoin and Ethereum. But these new studies showed that by refining quantum error correction, we could do it with fewer than 500,000 qubits. Another study from Caltech and Oratomic suggested that using neutral atom systems, we might only need 10,000 to 20,000 atomic qubits to run Shor's algorithm. A system with 26,000 qubits could crack Bitcoin's encryption in a few days. We aren't there yet. Current chips like IBM's Nighthawk are around 120 qubits. But the inference inflection, that moment when compute power explodes, is here. We just realized the wall we thought was 100 miles away is actually right in our backyard. This is the part that should keep you up at night. It's a strategy called harvest now, decrypt later. Sophisticated adversaries are collecting your encrypted data right now. Your medical records from last year? Stolen. Your private government communications? Stashed. They can't read them today, but in 5 to 10 years, they'll just run them through a quantum computer and read them like an open book. Companies like NVIDIA are already pushing for confidential computing, where not even the operator can see your data. But we need more. We need post-quantum cryptography, new math that even a quantum computer can't ghost its way through. The race is on. NIST in the US and the Australian Signals Directorate have set deadlines for organizations to move to quantum-safe systems by 2030 to 2035. Google is already speeding up its adoption of post-quantum cryptography in Chrome. But think about the scale of this. We have to rebuild the security of the entire internet while the old system is still trying to hold the doors shut. So, is it the end of the world? No, but it is the end of the set it and forget it era of security. Your bank, your blockchain, and your private messages are in a race against a machine that thinks like magic. Drop a comment. Are you more worried about your Bitcoin or your 2022 DMs? See you in the future, hopefully an encrypted one.